Okay, so what we're going to talk about is separable differential equations. Separable differential. Separable. Okay. And so let me give you an example. Again, what is differential? What's a differential equation? What is it? I didn't hear. All I heard was what the. What is it? It's an equation that has derivatives in it. Okay. So here's an example of one that is called separable, and hopefully you'll see why it's called separable. So I'm going to do a couple of them from the book. Dy dx is equal to x over y, and y equals 2 when x equals 1. Okay, so this is an example of a separable differential equation. It's a differential equation because it has a derivative in it, dy dx. It's an equation that has an equal sign in it. So what makes it a differential equation that has a derivative and it's an equation? What does it mean by separable? Well, if you look on this side now, okay, so if you look over here, I not only have just x's, but I also have y's. They're all kind of jumbled together now. So that's the difference. Before, when you did differential equations, we were solving for c, it was always the same letter on the other side. All x's, all t's, whatever. Okay? How do you recognize a separable differential? Either they'll tell you that it is, or you see that it's a derivative and then you have x's and y's on the other side. So the idea behind separable is very simple. What do you think I'm going to have to do first? I'm going to have to separate. Okay? So step one is to separate variables. I need all the x's on one side, all the y's on the other side, and that includes the dx's and the dy's. Okay? So, for example, if I would write this, if I would just cross multiply this, I would end up with what? I'd end up with y dy is equal to x dx. You see by cross, they're not all like that. They change, and I'll do a couple more with you. Okay, but that's what we mean there. So I have all the y's or y parts on this side. I have all the x's on this side, and so now I need to solve this for. What I'm trying to do is solve it for y. I want y equal to some equation. That's what you're trying to get, just like the differentials. But I have dy's and dx's attached to that. So how do I get rid of the dy's and the dx's? I have to integrate. Okay, so that's going to be step 2. Integrate both sides. So step 1, separate the variables. Pull them apart. Get x's on one side, y's on the other side. And you're always going to have a dy and a dx somewhere there. They have to match. Okay, so when you see that little dy, that is an indication to you that you want to integrate both sides. So what I'm going to write is this. Y dy is equal to the integral of x dx. What you do to one side, you must do to the other side. It's a big balance. You can't integrate one side without integrating the others. All right, so now we go into the rules of integration, and hopefully this is going to be okay to do. If I integrate y dy, I'm going to end up getting what? Okay, I'm going to get 1/2 y squared. That's if you integrate y. That's a power rule. Should be an easy one. And if I do the other side, same thing. So I'm going to get 1/2 x squared. But the difference here now on the other side, and you only do this to one side, is that it is indefinite. I don't know what the full equation is, and so on this side, I'm going to say plus c, and that has to be carried through the entire problem. Okay, so the only difference is here is that I had to separate up here in step one, and now I'm integrating two sides. Rather than just integrating one side, as you did before, I'm going to integrate two sides. Okay, now the goal here, now we go to step three, is want to solve for y. Okay, that's the goal. The goal is to get an equation in terms of y. Remember, we started with what? We started with dy dx, and what I'm trying to do is to get an equation in y. Right now, it's in terms of dy dx. Okay, so we come down here and we solve this for y. So what's the first thing I'm going to do if I solve this for y? I'm going to take it complete steps here so you see what I'm doing. What would be the first? I want to solve for y. Now you get y all by itself, so I need to get rid of this guy right here, which is 1/2. I'm going to multiply everything by 2. So we end up getting y squared is equal to x squared plus 2c. Okay? I'm just doing algebra now. And so now what's next? Square root, okay? So we're going to say y is equal to the square root of x squared plus 2c. And I'm actually only going to take the positive end of the square root. I'm not taking the negative. And you see, I don't think you guys have covered these at all, where you had square roots. If you have like a square root of plus or minus the square root of x, what that really means, it means half of it does this and the other half does this. No? Okay, forget that. Then just do the positive of it, okay? Unless they give a domain that requires you to do the negative part, but it'll be very clear. So yeah, I mean, unless it's stated completely, like it'll say, hey, for y is less than 0 or something like that, then you would have to do the negative part. But I haven't seen that, so that's why I think you're pretty safe in saying just do the positive part. But there actually is 2 halves. But the problem is when you do the 2 halves, if you know anything about functions, that's not a function. Did you ever learn the vertical line test, which says if you have a vertical line and it crosses the graph in 2 places, it's not a function? That's the idea here. So that's why I'm going to take half of it, not the other half. I can't take both halves, so I cross off 1/2 to make it a function. Okay? Again, it kind of dives into the math of this thing. All right, so what do you think is left? What do you think step 4 is going to be? Not finished. Yep. Okay. Solve for C. And I think we got some pretty good steps here. I mean, pretty simple steps. So if you're following this, pretty simple. Separate the variables, integrate both sides, solve for y, solve for c. Okay, now I have to go back to the beginning where it said y is 2 when x is 1. So it said y is 2. This was the given part. Given y is equal to 2 and x is equal to 1. So I go back to my equation. 2 is equal to the square root of 1 plus 2c. See, now I'm going to do some examples here that require you to do a little bit of algebra, and hopefully the pre-calc is going to come through here. I got to solve that for c now. So what do we do? Solve for c. Square both sides. So I'm going to square this side, and I'm going to square this side because I need to get rid of the square root. So I get 4 is equal to 1 plus 2c, and I hope the rest of it is okay. So c is going to equal, I move the 1 over, 3 divide by 2, so we get 3 halves. Okay, so finally we write our final equation, which will be y is equal to the square root of x squared plus, if I put 3 halves here, into C. Of course, that reduces to 3. All right, so it actually turns out that I started with dy dx was equal to y over x. It's implicit. It's not explicitly solved for dy dx. And so I did some work to it, and I actually can go backwards with an implicit. Okay? And that's the way you do it. You have to be able to separate. If you cannot separate, you cannot do this. Okay? But the good news is all yours are going to separate. All right? Any questions on how to do that one? That makes sense? Process? Okay? 4 steps on that? Of course, you got to practice when you do this. Okay. So let's try another one. Something that's a little bit different. That'll end up a little bit different. So here, example number 2. I'm going to let you do most of it. dy dx is equal to 2xy. Y, and it says, and y equals 3 when x equals 0. Okay, so what we're trying to find the equation of y. So they're giving me the first derivative equation. It's kind of all jumbled up. It's like implicit. And we're asked to find the equation of just y equals something. So you go through that process. So I'll have you try to do some of that. See how far you can get. See if you can get all the way to the end. Follow those 4 steps and see how far you can get. And then we'll come over if we need to. I'll go through it.